Laplace transform of derivatives. Okay, so what is the Laplace transform? We have already discussed Laplace transform of f of t, any function. Okay, now bounded function, of course, some conditions are there. So now we will discuss the derivative, Laplace transform of f dash t. Okay, or f double dash 2 and so on, higher order derivative of the function f. Okay, such derivatives of the function, and then we have to take the Laplace transform. Okay, so a Laplace transform of the derivative, say now f dash t. Okay, so f dash t is also function of t, correct? Derivative of the function with respect to t. Okay, so using the definition of the Laplace transform, okay, so it is 0 to infinity f dash t e to the power minus st into f dash t. Okay, so dt, that is the Laplace transform definition from the definition. So from the definition we will get, from the definition, correct, we will get this one. So e to the power minus st, so df by dt into dt, that one. So now e to the power minus st one function, f df by dt another function. If we consider integration by parts, okay, now integration by parts, okay, what we will get? We get Laplace transform of, okay, df by dt, okay, that is f dash t, okay, equals to this one remaining same, integration of this one. Okay, so what will be the answer? Now e to the power minus st into f, okay, df by dt means f of t, correct, and that is limit is 0 to infinity minus integration formula 0 to infinity. So now derivative of the first function and integration of the second function. So derivative of the first function e to the power minus st into minus s, t is the variable. Okay, integration df by dt means f of t, correct. So if I write again, so the answer is like that. Okay, integration, okay, df by dt and then dt. So again we have to consider this one as a integration. So this one. Okay, so now if we consider this one, what is the if we put first limit infinity, upper limit, okay, now so if we put here, it will give 0. Okay, e to the power minus st tends to 0 if t tends to infinity. So this one is 0 into f of t, it is 0. So now if we put the negative part, I mean, sorry, first part is 0, second part is e to the power minus st means 1 by 1, okay, into f of 0, correct. So f of 0 is not 0, say, okay. So minus integration 0 to infinity, minus plus, we can, since it is into all the integration with respect to t, we can consider this as outside, minus s. So minus s and minus, so plus s.
Sir,
yeah,
in that e power minus st into f of t, in case when t is infinite, we are assuming f of t is not infinite, no sir?
Not infinite, bounded. Since f of t is bounded function, so it is it should not be infinite. Okay.
Okay, sir.
So it is definition of the actually Laplace transform as well. The function should be bounded f of t. Okay.
Okay, sir.
So whatever may be the value of t, it will converge to some particular value. Okay. So now second part, to the power minus st into integration of df by dt means f of t, correct, dt. Okay, this part is nothing from the definition of Laplace transform. What is that one underline part?
Laplace transform of f of t, sir.
F
Capital
of
F of s.
Capital F of s. Okay. Generally, we are denoting that one capital F of s. Okay. Since integration capital F of s equals to Laplace transform of f of t. That is from the definition of Laplace transform. Definition of Laplace transform. Correct. So what we actually ultimately what we get actually that one we will write here. So I will it is this one. Okay. It is this one. Just 1 minute, but one phone call is there. Hello. Sir. No, sir. Executive engineer and office assistant. That is only one position, sir. So I think we have not given any age difference. Yeah. Okay. So what we actually ultimately, what is the Laplace transform of the function first derivative? Okay. So I can write here again Laplace transform of df by dt equals to s rearranging. Okay, now s into f of s f minus f of 0. Okay, so I can consider full part also or else this part also. Okay, so this is the formula. So no need to find all this integration again when you are applying this part. Okay, to solve any differential equation. So directly you can write this one. Okay, so now I will go to the next page to find the Laplace transform of second derivative, and then we will write so on. Okay, now similarly we can find the same thing. Okay, now differentiation. So sorry, Laplace transform of the differentiation. So next one is d2f by dt2. Okay, equals to Laplace from the definition. So equals to 0 to infinity. Okay, 0 to infinity e to the power minus st d2f by dt2 into integration with respect to t. Okay, so similar case. Okay, now we will take this one as a first function, remaining same derivative df by dt. Okay, integration with respect to that one, that means 0 to infinity. Okay, minus again 0 to infinity by parts. Okay, okay. So this one from the definition. From the definition, we got this one directly. Okay, now from this one by parts, integrating by parts. Okay, now integrating by parts. Okay, so what we are getting, that one we are writing here. It is e to the power minus st into minus s. That is the derivative of this part. So this part is derivative part. Now integration part. Okay, integration part of this one d2f by dt2 and then dt and then total. Okay, total. This one is integration part. Okay, total is dt with respect to integration with respect to t. So same thing here it is. Okay, so since f of function f of t is bounded function, the derivative also will be bounded only. Okay, so this part again we will get like what we will get df by 0 minus df by dt. Okay, at t equals to 0. So infinity, this is for the upper limit, this one is the lower limit. Okay, so 1 into this one. And
Sir,
yeah,
derivative of bounded function need not be.
no problem, but we'll get some particular value. So it is 0 if it is infinity also. Okay, so function it should be defined. Okay, and that derivative should exist. Okay.
Yes, sir.
Otherwise you can't find the second derivative better. You just think about this one. If this one is if this one does not exist, how can you find the second one? You just see my arrow I am giving.
Yes, sir.
Clear? Okay, it's okay. So in that sense, you can say if this one exists means the second one, otherwise you can find this one. Okay, so next one. So minus s into s, sorry, minus. So what will be the answer here? It is, you can write s outside 0 to infinity. Okay, e to the power minus st. Now the right hand side, integration with respect to f, sorry, t. So we can find, or we can write like that, into dt. It's okay. This is integration df by dt. Sorry, d2f by dt to integration of that function. What will be the answer? Df by dt. Correct. Integration is the reverse process of differentiation. So now, what is that one? This one we can write minus f of t at t equals to 0. Correct. So sorry, f dash t equals to 0 plus s into okay, integration 0 to infinity e to the power minus st df by dt into dt. Same thing I have written. What is this? This one is minus f dash 0 plus s into Laplace transform of df by dt. Correct? What is the Laplace transform of df by dt?
Minus f of 0 plus s Laplace transform of s.
Okay, so now I will write this one again in that form. So minus f dash 0 s into, just we have to use the previous result. Okay, now just earlier page I will go previous page. Okay, let's see this one, the box one. Okay, s into f of s minus f naught. Okay, now so go to the next page. So s into, okay, s into s f of s minus f naught. Correct. So now if you multiply and if you simplify it, we will get s into s square f of s minus s into f of 0. Okay, and then minus f dash 0. F dash 0. Okay, this one I will write here again. Okay, the final form. Okay, so what will be the final form of this Laplace transform from the definition? Okay, so this one is just s square into capital F of s minus s into f of 0 minus f dash 0. Correct. But actually from the earlier page we can write s into f of s. What is the answer? F of 0, na? This one. Is it correct? This one. Okay. df by dt Laplace transform s into f of s minus f naught. Correct. Okay. So now I will go to the next page. D3, this one. Okay, Laplace transform. I think we know how to derive it again. Correct. What is the answer, sir? Just see. This is we will solve. Okay. This two.
S cube capital
Okay, tell me. S cube
capital F of s minus s square f of 0 minus s f dash of 0 minus f dash of 0.
Okay. So I will write next is capital F of s. Correct. Minus s square. What you told?
F of 0
F of 0. Then
minus s f dash of 0.
minus s of 0. That's all. Or something else.
Minus f double dash.
So if it is u, we are starting with 3. Okay. Since it is u, ending with 1 minus. Correct. So here it is like that. And it will be 3 only also. So you can remember that way. So Laplace transform of dAf by d. Okay. dN. This is answer. Just say first and two step last. Okay. First term s to the power n into capital F of s minus s power n minus 1 about 0. Then we will write and last two.
Just into f dash of 0 minus f
Minus
n minus 1 of 0.
so what
Minus the derivative of f, sir.
okay, this one or minus 1. We would have just 0, but is it f dash 0? S into f. What is the derivative? N minus 1 or n minus 2?
N minus 2, sir.
N minus 2. Correct.
That's not n minus 2, sir, because the second term is s power n minus 1, which means third term will be n minus 2, sir. That is
N minus 2.
sir.
Oh, okay. But if it is third order, what is the last derivative?
Second, sir.
Second.
That is the only last term, sir.
Last only I am writing, na?
Like you can take n minus 2 for last.
Yeah. Okay, correct. S square. So it is s square, correct? So minus f, here it is n minus 2 or n. I have written wrong. Total.
Okay. Sir, that's wrong, sir.
What is this part? If we want to rectify, what will be the correct one? That two part is missing. This part and this part. Minus s into f of. Again, part is missing. This power and this power. This one. Minus f of this one. Question mark. Okay, now 0. Okay. Tell me.
Last term question mark is n minus 1, sir.
Okay. Now somebody else should prompt it. Okay, now next one. This one.
N minus 2, sir.
Minus s. F of
Yes.
n minus 2.
2 of 0.
Correct. This one.
N minus 3.
N minus 3. 0. Everybody agree with this one? Then we will stop here and we will go for the this what is wrong. Okay. So this is the nth order derivative of the function, of the function f of t. Okay. Now we will consider one application. New page. Applications of Laplace transform. Okay. Similarly, integration also we can find the integration Laplace transform of integration. I will come to that one later on. Okay. Now, first, now we'll consider one application. Means if I give one differential equation, easily you can solve using so many methods. Okay. Now, okay. But our target to find the solution of a ordinary differential equation. Okay. Solve by using the Laplace transform. Solve the ordinary differential equation. Okay. Using Laplace transform. Okay. So d2. Okay. d2. That is say. Okay, we'll write d2x instead of that one. d2f by dt2. Okay, plus 5 df by dt. Okay, plus 6f equals to 2 e to the power minus 2. So what is here? It is t greater than. Puts t greater than equals to 0. Now, what is f? f is a function of t, correct? So what is our what we have to do? What we are actually what we have to find?
Solution, sir.
We have to find f of t, correct? Is a function of t. This is correct. So our target is to find the f of t. Clear? So now solution of the given differential equation. Okay. What we have to do? First, we have to take the Laplace transform of both sides of the given function. Oh, sorry, given differential equation. So now taking Laplace transform of both side of the given differential equation, given ordinary differential equation, we get Laplace transform of d2f by dt2 plus 5 df by dt. You should have pen and paper. I will stop somewhere. Okay, no? After that you have to complete it. So this one, sometime Laplace transform of 2 e to the power minus t. Okay, we know that Laplace transform holds the linearity property. So left hand side we can write, okay, that is using that one, using linearity property of Laplace transform, we get separately L d2f by dt2 plus 5. Since I have to go to the next page, I can't see the first page. Okay, now this page. So I will ask I need input from you people only. Okay, now sorry. F of f equals to Laplace transform of Laplace e to the power minus t. Correct. So actually before okay, before we go to the next step, I have some query. What is the order of the differential equation? What is the order of the differential equation? 2. So, and for that solution, how many conditions you need actually? So if you are not applying
sir.
2.
Yeah, no initial conditions are needed, sir.
Yeah. So actually, if we solve this one using the using the analytical concept, we need 2 conditions. So that one is missing. I will add here. Okay, you can write now. So x equals to 1 at t equals to 0. That is one condition. Correct. So the conditions here it is. Conditions. Okay. And f equals to 1 equals to ordinary differential equation. Generally we are habituated with like that d by dt. No? So f equals to 1 at t equals to 0. So and what is the next condition you need? df by dt. Correct. F dash t. That one is 0 at the same point t equals to 0. Okay. Oh, where is the cursor? Yeah. So okay. So now the second condition is this one. Okay. So second condition is at t equals to 0. Okay. So these are the 2 conditions. And moving to the next page. Okay. So now you have to give you should give the input of this Laplace transforms. So what are the Laplace transform? So I need answer from you people this one. Okay. This one, result of this one, and result of this 4. Okay. One by one, you can answer. Next page. Tell me. That implies we can write first Laplace transform of d2f by dt2. What is the answer? I will write. Anyone?
S square
square
Laplace transform f of t.
f of t. Okay, f of t or f of s? S, no?
F of S.
F of t Laplace transform is, say, that is standard. Okay, na, capital F of s. So s square into f of s. Next,
minus s into f of 0.
minus s
So f
into
dash
f of 0 minus
dash of
f
0.
dash 0, f dash of 0. So that is the first part. Okay, na? First part. I should not use second bracket. Okay. Now next part. What is that one? I can't see it. Just tell me. Plus or minus?
Plus 5
Plus 5 into something is there. What is that one? S into f of s. I think that one will be there. Next,
Minus F of 0.
minus f of 0. Okay. Last one. That means from the left hand side,
Laplace
last one.
transform of f of s.
Plus or minus?
Plus 6.
Plus 6. Capital F of s. Correct now. Only f of t is there. Okay. What is the right hand side? Equals to
2 by s plus 1.
Laplace yeah, 1 by s plus 1. Say. Some constant into 1 by s plus 1.
so 2 is there. You are telling 2 into f e to the power. What is the right hand side? The function
Power
original
minus t,
function e to
sir.
the power
So
minus
1 by
t.
s plus 1.
So 1 by s plus 1. Okay. Now left hand side you have to simplify. So okay, before that you can put this one is, this is initial condition is given, I think so, at t equals to 0. What is the f of 0? Sorry, f of t?
1, sir.
1.
I guess.
Okay, so s square f of s. Okay, right. Using the given condition. So condition we get, using the given condition we get minus s into, what is f of 0? What is f of 0? 1. Okay.
Oh, 1.
1
Okay, 1.
minus f dash 0. F dash 0 is
0.
0. So plus 5 into s into f of s. So f of 0 you told 1. So minus 1. Okay. Plus 6 into f of s equals to 2 by s plus 1. Now you can check what is capital F of s. Capital F of s into, I can write s square 5s 6. So 5s plus 6. Okay, this one.
Sir,
Now, yeah.
that 6 into capital F of s,
Hmm.
that we had Laplace transform of t, no sir? That is
No, not t. F. dy dt. X. Sorry.
Oh, that was the last term.
Yeah, last term.
Last term was 60, no sir?
Last term is, I have to go back then.
60.
No, 6 only, na. 6 into
Oh,
f.
60.
This one.
Okay, sorry, sir.
How you can write t? Here
Sir,
it is
it looks
only.
like t, sir.
Yeah. Better that. Okay, if I write x, then it will be better, I think so. Okay, na. That is the
Sir,
equation,
it's
a
okay,
differential
sir.
equation.
It's okay, sir.
But since we have studied only f of t, that's why I am writing. Okay, na.
Yes, sir. Yes.
Okay, now we just see we are segregating. Okay, the coefficient of f of s and the rest part. Okay, now. So the rest part minus s. So minus s, if we take right hand side s, here it is 5 into minus 1, so minus 5, so plus 5, and plus 2 into s plus 1. Anybody having any doubt? Correct now. So now this is the part. Now what is we can write? Our target is to find the f of t. Okay. How can you find? If you take the inverse Laplace transform of capital F of s, then only we can find. So that's why left hand side only f of s, and the right hand side in terms of s. So s plus 5 by, is it 5 or something else? Correct only, na?
Correct.
Okay. So s square plus 5s plus 6 plus 2 into s plus 1 into s square plus 5s plus 6. Now you understood now what we have to do. What is the next part? We have to take the inverse Laplace transform of both, correct? And we have already studied that one. So the by taking inverse Laplace transform of both sides, we get inverse Laplace transform of f of s equals to inverse Laplace transform of s plus 5. Now I don't have any duty. You have to find all the inverse Laplace transform. Then you have to answer. You have to give the s plus 1 into s square plus 5s plus 6. Now I want. So only left hand side I can write it. Right hand side you have to find. Left hand side I know. What is the left hand side? L inverse capital F of s.
F of
Of
t.
t.
Okay, that is the required solution or not? That is your required solution, correct? F of t in terms of t. So you just note down the last line, right hand side, and I need output from your end. Okay, better to okay. First, for odd roll number, we should not wait so much time. Okay. So for this part, odd roll number, this one you for the even roll number. Okay. Since odd come first, no 1. So that's why I have considered. I have not given any partiality.
Sir,
Okay.
but all part I already solved, sir.
Solve. Okay. Good. So is it your roll number?
44, sir.
Then we have to find the right hand side only.
Yeah, like before you said,
You are-
I started solving this. Sir.
Okay, no problem. Then I will take your answer. Don't worry. Okay, now. So I have to go to the next page since there is no space. So I will go to the next page. So f of t, therefore the required solution is f of t. So rule number 44. What is the first one?
I got
S
A
plus
as
5.
3 and B as -2, sir.
Once again, you tell me.
A is equal to 3,
Okay.
B is
And
equal to -2, sir.
oh, so that is actually you are telling 3. I'm writing. You just tell me it is correct or not.
Sir,
This one.
3 by s plus 2 minus 2 by s plus 3. That's it, sir.
Oh, that's it. Okay. So sorry. Laplace inverse transform. So Laplace inverse transform. This part from the odd roll numbers. Okay. Even if some even roll numbers also can find now since already this one is known. Okay. 44. What is the answer of this one?
Which one, sir?
I have given underline. You just check it. Laplace
Sir.
inverse of
That
3
is
by s
3 into e power minus 2t, sir.
minus 2t. Okay. And the next one is
Minus 2 into e power minus 3t.
okay. Okay. So now I am waiting for the rest part. What is that one? 2 by s plus 1 into s square plus 5s plus 6. So s square plus 5s plus 6 means actually already that fellow written s plus 3 into s plus 2. So s plus 1 into s plus 2 into s plus 3. Okay, I will go to the next page. So Laplace transform of here. Is it plus or minus better? It is minus or plus?
Plus only, sir.
Plus only. Okay, thank you.
So the answer is 1 by s plus 1.
1 minute, but I am writing. Just okay. Okay, tell me. No, can you tell me the fraction first? Okay, don't send SMS. Okay, or any chat. Don't put anything in chat box. I can't see chat box. Okay, now. So now L inverse. Just tell me the fractional part first. Then I will.
1 by s plus 1
1 by s plus 1
minus 2 by s plus 2
s plus 2
plus 1 by s plus 3.
whatever I have written, it's correct or not? Okay, is it correct what I have written? L inverse 1 by s plus 1 minus 2 by s plus 2 plus 1 by s plus 3. I think somebody should confirm this one. Only one fellow has given this one. I don't know this is correct or not.
Solving, sir.
Okay, okay, do it.
Sir, correct, sir.
Oh, what is it? Good. Okay. So now 3 e to the power minus twice t minus 2 into e to the power minus thrice t plus 1 by 1 plus s. What is the answer?
E power minus t.
E power minus t minus 2 into s
E
plus
power
2.
E power minus 2t
Okay, next.
minus e power minus 3t.
Minus or plus? Plus, no?
Plus.
E to the power minus 3t.
Yes.
Okay, for t greater than equals to 0. So now, if we simplify, the recorded solution is f of t equals to 2, 3. This one is matching. This one also matching. Correct now. So you can simplify it. What will be the answer? Okay, just. Final answer. F of t equals to the solution of the ordinary differential
e to the
equation.
power minus t
E to the power minus 3
plus e to the power minus 2
e to the power minus
minus
2
2t
to the power minus 2t
minus
minus
to the power minus 3t.
e to the power minus 3t t greater than equals to 0. So if I ask you to find the solution of the given ordinary differential equation, you can solve directly. I know that one. Okay, now if I go to the previous page, let's see. If I ask solve this differential equation, and if I not mention this one, okay, easily you can solve with this condition. Am I correct? You already studied this one. Yes or no?
Yes, sir.
Okay, but now, okay, only the problem is this right hand side. Okay, now since e to the power minus t, it will take little bit time. Correct? So that particular integral. Correct now? I know this one is complementary function is nothing. You can easily find it, but particular integral it will take some time. Correct? But here it is at a time you can find the solution. Okay, and the solution using the Laplace transform is this one. But okay, since this semester you are studying Laplace transform only, so if I given any differential equation, you have to apply ordinary. Sorry, you should not apply any analytical method. Okay, whatever you have studied, you have to use this method only. Okay, so now I will give you some problem, then we will stop this. Okay, we will close this class. Write down. Solve the ordinary differential equation. Okay. solve the ordinary differential equation. Okay. Uh, solve the ordinary differential equation using Laplace transform. Okay. So now first one is this one. First problem. So I will give you the 4 problem. Okay. For practice only. No need to send. Okay. Don't send to me. Okay. D2. So the function is f of t. Okay. So you have to find the solution like that. Okay. Now. So d2f by dt2, okay, plus dx by, oh sorry, df by dt, okay, minus 2f of t, okay, since f or t is similar, so like 5 e to the power minus t, okay, sine of t, okay, this is subject to conditions. You need some 2 conditions. Okay, now that one is f of t, okay, equals to 1, okay, at t equals to 0, and f dash t equals to 0 at t equals to 0. You same conditions. Okay, just few minutes back you have studied one ordinary differential equation. Next one is, okay, next one is should I give you the third order differential equation? So it will take a little bit time. Okay, let us. I will give one third order, second one. Okay, now. So d3f by dt3 minus 2. Okay, d2f by dt2. Okay, minus df by dt. Okay, plus twice f of t equals to, so right hand side is easy one. Okay, since it is third order differential equation. How many condition you need? 2 or 3 or 1? So this
3,
is
sir.
3. So 3 conditions are here, right hand side. Okay, now. So okay, 3 conditions are like that. F of t. Okay, then f dash t, and then f triple dash, sorry, a double dash t, not triple dash. Okay, at, so this one is first you write 0, 1, and 0 at, okay, at t equals to 0. Correct. This is the condition. So this condition. Now third one, simple problem. Okay, once again. So this one is like that. This one, d2f by d. Okay, always f means not good. Okay, now dt2. Okay, plus 4 dy by dt. Okay, plus 5y equals to 3 e to the power minus twice t. Okay, condition for this problem, 2 conditions are required. First one is y equals to, y of t equals to 4, and y dash t, okay, equals to minus 7. The condition at t equals to 0. Okay, okay, that this 3 is enough. Okay, so just complete all this problem. Okay, no need to send to me, just you text for your practice purpose only. Okay, do you have any query? For all of you, there is no odd even roll number. Okay, for all of you, you just solve all these 3 problems for the practice purpose only. I have given. Okay, next class we will see your syllabus format. Then we will discuss regarding the simultaneous equation. Have you studied solution of simultaneous equation? Simultaneous equation means at a time more than one solution. Yeah, I'm not getting. Yeah,
No,
yeah,
sir,
tell
I
me.
didn't
Okay.
study that.
Oh, you have not studied. Okay, okay, okay. No problem. Okay, I will check your syllabus once again. Using Laplace transform, even you can solve two system of equations at a time. If your syllabus permit, I will check once again syllabus. If your syllabus permit, then we will consider that type of problem. Otherwise, you will go for the next topic with Laplace transform. Okay. Okay, then that's all. If you have any query, you can ask me now. Otherwise, you can leave the meeting.